This is 7.5, Analyzing and Sketching Graphs. Graphs can show the relationship between quantities without using specific numbers on the axes. So we're going to look at, they're just going to be pictures of graphs, but no numbers on there. So to analyze them, we're going to do an example. So the two graphs show temperatures throughout the day in two different cities. So I have city A and city B. We can see that they're different. We're going to describe the temperature change in each city. So city A, the temperature increases at the beginning of the day. It's going up. Then it reached a high near the middle of the day and then decreases at a fast rate later on. City B, the temperature decreased at a steady rate. We know it's a steady rate because it's a straight part of a line. Then the temperature stayed the same, and then it increased again for the rest of the day. So a straight line means a constant rate. If we sketch graphs, we're going to sketch the graph of this situation. An airplane accelerates at a constant rate until reaching its maximum speed. Then it flies at this rate for a while, then decreases at a steady rate until coming to a complete stop. So, I'm going to have time on the bottom. Time should always be on the bottom, and then speed should go up and down. So it increases speed at a steady rate, then it flies at that speed for a little bit, then decreases all the way down to when speed is 0 to show that it came back to a stop. The graph shows the distances traveled by two race cars in a race from start to finish. Describe the speed of each car throughout the race. Who won? So I have two different lines here on my same graph, race car A and race car B. So for A, we would say that the speed increases at a steady rate, then he stopped. The distance did not increase during this time, so we know he wasn't going anywhere. Then they increased again at a constant rate. Race car B increases throughout the entire race and continues to go faster and faster, never at a constant rate. So B is never a straight line, so there's never a constant rate there. To figure out who won the race, we have the time for race car B was down here, and then the time it took for race car A was a little bit more. So we know that race car B won because it reached the distance in a shorter amount of time. Alright, and one more example. We are going to sketch the graph. So we have two runners. Runner A runs at a steady speed the entire time, and runner B starts sprinting, then walks, then sprints at the end. They finish at the same time. So I would have my graph, distance and time, and A is at a steady rate the entire time. So they just have one diagonal line to represent their running. Then B is going to be steep at first because it's fast, it's sprinting, then slow, so more flat because they were walking. They're still increasing distance, just not over a short amount of time. Then they sprint at the end again, so it's going to be steeper at the end. And they finish at the same time, which means that they need to be at the same point, so they connect at the end.